Today I'm going to teach you my entire workflow for working with Astro data in Siril, and by the end of this video you can have a picture that looks something like this, because this is a edit along video where you can download the data and you can edit along yourself as you're watching this video, because I believe this is probably one of the best ways to learn the tools by trying to do it yourself. Hello and welcome. Now, first order of business before we start is of course that you need to go to the link in the description. You can download the zip archive where you will find all the data you need in order to edit along with this video. Once you got the zip archive, unzip it in a folder where you have quite a bit of space, probably around 100 gig of free space, as we are going to be using quite a bit as we are doing all these intermediate files before we get to the end result. And you should have something that looks something like this. Let me just run you through it so we know what we have here. Now we have of course our folder here with all our biases in their raw format, and these are in what's called a fit format. This is a very common format used by most Astro cameras these days, and this is just an image format, just like JPEG, PNG, anything else. The special thing about these fit format files is that they contain a lot of metadata that is specific to astrophotos. Stuff like the right ascension or declination, like where was the telescope pointing on the night sky? What is the telescope specs was it shot with? All those kinds of things that you normally wouldn't have in normal image formats are stored in these fits files. And we have our biases, of course, as I said, we have our darks and we have our flats. Now, these are all calibration frames that we're going to be using to calibrate our pictures to reduce noise. And if we go into the flats, you will see that they are labeled in an H, O, and S. And this is because we're dealing with monochrome data. So this is not color images. We're going to be making it into colors later in this video. But these are shot with narrowband filters. That means they're shot with hydrogen alpha, oxygen, and a sulfur filter. And we're shooting the same target with different filters. And that also means we need to have flats for the same. And the actual light, the actual images with data in it, it's the light frames. And again, they're also, of course, also divided up into the hydrogen band, the oxygen band, and the sulfur band. This is the type of imaging you would see coming out of stuff like Hubble. And we're actually going to be using what's called the Hubble palette today. So we're going to get something that looks Hubble-esque when we get to the end result. The reason I took this data set specifically for this video is because there wasn't that much data, because file's already rather large to download. I didn't want it to be too bulky, and we can get a decent result out of this. And it also means less data. It just means it's easier, it's faster to do, works better for these kind of tutorials, while in real life when you do pictures you might want to get more than I have here. Great, but let's jump back to the main folder, and we're going to do two things before we start actually editing. First, we're going to create a new folder, and we're going to call this one for process, because Siril is going to create a lot of intermediate files, and we don't want those files clogging up our main folder here. It's just going to be a mess. So we're going to make a process folder where we can dump all those intermediate files. And then this is a personal thing, but I like to also make a master file or master folder. And that's just when we have our finished master files. We'll begin to stack these images in a second. Then we can put those in there so we know that that's where we find all our masters. Awesome, we are in Siril. Now, first step that we are going to do is we're going to go up here to the home icon. We're going to click that, and we're going to navigate into the folder, and we're going to jump into the process folder, click on that, and click open. We're then going to verify up here, center top, that it's pointing us into the process folder. When it does that, it means now we're ready for the first step. And that is we're going to begin to work with all our calibration frames. So let's go and click the plus here, navigate back, go into our bias folder, select all our biases and click add. Now, the first thing we're going to do in Siril is we're going to create a master bias. So we're going to take all our biases that just measures the base background noise levels for the camera. We're going to take all those measurements and we're going to make it into one master bias. And we're going to do that by just first creating a list. In Siril, that's called a sequence. So we're just going to basically take all these files and make it into a single list so we can work on the entire list of files at the same time. We're going to name this list or this sequence for bias down here. Now, since we're working with mono data, we don't need to click the debayer. If you're working with color data, you need to click the debayer icon here, a little check mark here. We are not, so we are not going to click it. Now that we have named our sequence, we can click convert, and this should take almost no time at all. There we go. And if we go into sequence, we'll now see we have a bias_.seq as our only sequence right now, and that's good. We just make sure that sequence is ready. Now we can skip. Normally we would go through these tabs one at a time, but today we can skip it. We don't need to do any calibration, registration, plot, and we can go straight to stacking. Now, here we need to make some changes to the settings that need to be specific to our biases. Average stacking with rejection, we're going to keep that here at the top. For the normalization method, we're going to swap that over to no normalization. For the pixel rejection, we're going to keep the windowed sigma clipping. And for the weighing, we are going to put that up to none. The rest of the settings, we're just going to leave as is. Apart from save in, I like to rename this, so we call this one master bias. And now we can click start stacking. And Siril will now take all these pictures, stack them on top of each other, and create our master bias frame. And we can see here, it took me 1.88 seconds, so just shy of 2 seconds. And if we jump now to a process folder, we can see all the intermediate files I talked about. And we now have here, find the master bias file. Let's just make a copy of that. Oops, copy of that. And dump that in our master folder. So now we know that is safe. Great, we've created our first master file. It was easy. Now we can go back here to the conversion tab, Control A, and you can either just go minus or you just click this icon here to clear the list. So now that we've done our biases, I think it's time that we do our darks. So let's go in, let's select all our darks, put in there. We're gonna change our sequence names over to darks, and then let's click convert. There we go, took half a second. We're going to jump into a sequence, and we can see now that we now have both our bias and our dark sequence, and we're going to make sure we're on our dark sequence. Once again, we can skip calibration, registration, plot, and go straight to stacking. And we're going to use the exact same settings to stack our darks. Of course, we're going to name this master dark, like so, and click stacking. Again, this takes no time at all, and we should now have a master dark down here as well. We can do the exact same thing with. Dump that in here. Now we get to the flats, and they are a little different because, as you might recall, when we go in and we look at our flats, we have them in different bands, and we're going to have to process these bands one at a time. So let's start with our hydrogen. Select our hydrogen data, add it in here, and let's call this one for flat_H, so we know this is the hydrogen flats. Again, we click convert. We go over, we ensure that we are on the hydrogen flat sequence, but now we actually need to do some calibration. Because for the flats, we do need to subtract our bias levels, because there will be a bias level in the flats, which we need to subtract. So we're going to do that by saying use bias. Then we're going to click the open icon here. And we're going to go and navigate to our master bias frame there. Add that in there. We're going to disable the enable cosmetic correction, like so. And the rest here is just kept standard. You can see here that it says output prefix is PP. That means it now creates a new sequence with the calibrated flat files. So if we go and say start calibration, and we can now see in our sequence that we now have both the hydrogen flat sequence, but also the PP for pre-processing hydrogen flat sequence. And we're going to make sure we are on that there. Jump over to the stacking, and here we again need to make some changes. Now the normalization method, instead of having no normalization, we need to put that over to multiplically, like so. And that's the only change we need to make here. Of course, name this for master flat, and H for hydrogen. And we click start stacking. So your master flat, there we go, this one. Okay, and as you can probably imagine, now it's just the same process again for the other filters. So we're gonna go delete the hydrogens. We're gonna go in, we're gonna go for flats. Let's go for oxygen. And then we're gonna change the name here to O, because now we're working with that. Click convert. Go to calibration, click start calibrating, go to stacking, Again, we're going to keep the settings and just rename this to master flat O. Now we just need to do it for the last filter as well. And with that, we now have all our calibration frames pre-processed, and we're now ready to actually work on some of the image data. Now, let's go ahead and take a look at one of these frames before we actually start working on it. So let's just go in here and just take one frame, dump it in, let's take a look at it. Now, by default, when you open the frame, you're not going to see anything. And that's because the data is still in its linear state. That means it hasn't been stretched, but the data is there. And we can actually see it if we, instead of going linear, say, apply an auto stretch. This is not going to change the data, it's just temporarily so we can see what's there. And there you go. We can now see a single frame here, and we can faintly see the outline of the hard nebula here in the data. And it's quite faint, but it's gonna get a lot more strong here in just a minute. This is just down to pure signal to noise right now. As I said, when we begin to stack it, we're gonna begin to see a much stronger signal. This is quite satisfying actually. But let me show you how you process your lights. We're gonna go ahead and we're gonna clear out our selection over here. And we're gonna pick our first filter. So let's go in for the lights, hydrogen, select our hydrogen data. And we're gonna call this one for light with an H for hydrogen. And we're gonna start again by clicking convert. So far it's pretty similar, but this is where the similarities end, because now for the calibration, we do not need to use the biases because we use those on the flats. So mathematically, we actually don't need to subtract them now for the lights. They are kind of like built in, if you will, to the to the darks now, because we didn't subtract them from the darks. So we can just take them and go, and here for darks, we're gonna go and pick our master dark. And for the flat, we're gonna pick the master flat for the hydrogen filter, because we're doing hydrogen right now. Open that, make sure those check marks are set. And now we want to re-enable the cosmic correction here, like so. And once we've done that, we can say start calibration. Awesome. So now we have our pre-processed flats and we're done with our calibration. We can now move on to what's called registration. Now what registration does is it looks at the stars in the picture and it tries to align the pictures up. So it's just like a little rotation between each picture. Maybe there's a bit of a shift because the telescope moved a little bit or whatever. There will always be small like inconsistencies between them, and we can see those in a second. But it just calculates how much each picture has been shifted according to each other so that they can all be perfectly aligned on top of each other when we stack them. We didn't need to do this for all the calibration frames as there were no stars in them, but now there is. So now we actually need to make sure that we have that perfectly aligned on top of each other. So you go up to the drop down here and we're going to use the global star alignment. You can't use a 1, 2, 3 star registration. It's a bit more manual. I highly recommend you use the global star alignment. So we're going to go ahead and pick that. There is a few ways you can do this. You could just go and click register now and it will likely work. I like to do it in a 2-pass because you can see if we hop over the 2-pass, it means that it calculates the registration data. So it calculates the shift for how much this has been shifted around, but it does not apply to it yet, and this allows us to actually look at how much shift there is before we apply it, so that we can filter out any like frames we might not want. So I like to actually do a 2-pass registration, but you can just go and do it in one go if you prefer to do so. But I'm gonna put it here. Now, when it comes to registration, it's a bit of a trial and error kind of thing, because it really depends on your data. Sometimes you can just go with the default settings as you can see them here, and it's gonna work fine. Sometimes you might have sit and play around with it, change the maximum number of stars around, maybe try to reduce this to lower options here to make it more simple. There are loads of things you can do. But for now, let's just keep the default settings and see if we're not lucky, and this should just work in the first go. So I'm gonna click go register, and what we're looking for here is at the end, it says here total 0 failed, 10 registered. Awesome, worked as we wanted to. If you have things that fails, you go back to your registration, you try to change your settings and see if you can get more of them to register. Try to get as many to register as possible. Now, as I said, right now we've calculated the registration data, and we'd actually see it now, because if we go over here and we open the frame list, You can now see here, this is the frame that we have open now that's been used as the reference, frame 7. And here you can see the shift in the X and Y direction, how the images then shift over time. We can go and click on the individual pictures, and we can see out here, we can kind of see how that, it looks like there was a bit of a cloud there since it's so dim. You can see there's a lot more data here in some of the later ones. That's going to be important here in a minute. But we can see it here, and we can sit and look through the frames. But what we also want to do is we want to jump over to the Plot tab. What the Plot tab does is it shows you the individual frames that we have our 10 frames here. And as you can see up here, we have what's called the full width half max. That's kind of the, it's how do I describe that? It's like how blurry is the picture. So a high full width half max is very blurry, and a low is not very blurry. There's a bit more to it than that, but overall, it's a measure of the quality of the picture. What we're looking for here are extreme outliers. We can see we have one here, and maybe we're like, what went on there? That looks kind of weird. So let's just show frame 2. Okay, here we have frame 2. Apparently, that's the blurriest picture of the ones we have. So we could choose, if we wanted to, we could choose to right-click and exclude this frame and say, you know what, we don't want that one. That's not very pretty. Now, because we have so little data, we're going to keep it all. And it's not really bad. Again, if we look at the scale here, down here, this is 2 and this is 2.7. So keep in mind that this is not zeroed on the zeroed on the y-axis. So I would probably just keep all the data as is. It's not terrible at all. We go ahead, go back here to our registration tab, and now we do the second pass of the 2-part registration. Saying applying registration. Now, you have some options here you need to consider. First of all, the framing method. Here you can choose either current, which means it takes the current frame and it just says that's the view you're gonna get no matter what the others do. You can also go and say maximum, then it just takes, as you can see, you get the green area around where they all are. That's gonna create a lot of noise on the edge, so I wouldn't recommend using that. Unless you absolutely have to. Minimum, just the area that covers all of them. And center of gravity is kind of a happy medium, if you will. Now, because we're gonna be stacking these on top of each other, it's kind of important that we keep the frame resolution, the frame size, the same on the different channels. If you're using color data, you can more easily go and use some of these others, use center of gravity or use minimum if you want to. But when you're working with mono data, you always want to use current so that you keep the frame resolution between each of the different filters that we're going to be running with. So we're going to use these settings here, as you can see, and we can click Go Register to now go and apply our registration data. There we go. Okay, registration has been applied. And we're now on the registered pre-processed light hydrogen sequence. And now we're ready to stack these into our master hydrogen frame. We're going to make some changes to that also. First, we're going to change our normalization method over to additive with scaling. There we go. And down here in the pixel rejection, we're going to change the weighing from none, over to weighted full width half max. That was the same value we looked at before, kind of the blurriness of the picture. What we're saying now is we're just saying, hey, let the sharpest frames have the highest impact on our end and give less importance to more blurry frames. We're still going to use some of the data to kind of get the data we can, but the sharpest frame is going to have the highest impact, which is great. Now, if we had deselected some frames, you would have noticed this has gone down. And this is a point you need to be careful with. If you deselect frames, this will default be on all, but you might have to move this over to selected. But since we did our selection before we created the registration sequence, because we did it in a 2-pass, we can leave this on all. So now we are ready to go down, give this a name, master light hydrogen. And now we can click Start Stacking. And look what happens over here now. Boom. Did you see that? How much brighter it got, how much more data we got. Now we can really begin to see some of the structures in here. This is our first master light frame, and we're really beginning to see some stuff going on over here now. Awesome. So let's go ahead and let's quickly go and save that master file. We can just sort this by time, so it should jump on top here. Master, put that in. Okay, so now we need to repeat the process for the other filters, but luckily now all the settings are there. It's a lot easier here for the second time around. So we need to again go light. We just did the hydrogen. Let's do sulfur now, just for fun. Add sulfur, change the sequence name over, click convert. Boom, that's done. We are checking our sequence. For the calibration here, remember that we have a flat for each channel, so we need to go and change our flat, master flat, over to the sulfur. There we go. So that is now set correctly here. And now we can click Start Calibration. And from here on, it's just going through the tabs one at a time. So that was calibration done. Now we can go to registration. We already have the settings. We need to go, of course, put this back on global. Star alignment first. Go register. When we do the whole thing again. See, one failed here. So now we might actually maybe consider going back and saying, okay, can we do something here if we try to change some settings maybe? Can we get this to register? Oh, there we go. We of course need to say register all images in sequence, not just selected. There we go. Try to go register that again. No, still have one that fails. Okay, what we can try also, that sometimes work, I'm not really sure why, but sometimes we're just gonna go in here and verify that all 10 frames are in fact selected. Go to registration and then try to do it in a 1 pass instead of a 2 pass. Just to see sometimes doing it in the 1 pass works better for some reason. I can't really explain why. It should be the same. But we can try and see we're lucky this time. No. Now there was actually 2 frames that fails this time, so we got an even worse result with the 1 pass. There we go. Okay, so eventually, if you just keep playing around with it and you just can't get this registered, at some point you're just gonna have to cut your losses and say, you know what, we lost a frame that we couldn't register, and we're gonna have to move on. So look at our plot. Plot looks fine. Range here is okay. And we're gonna go and do the exact same thing as before. We're gonna apply our registration. Check our sequence list here with the registered pre-processed light S frames here. We should have 9. We do, so that's good. And now we can go and do our stacking. Give it a name and stack. And again, it's not uncommon that you will lose a frame or 2 doing the registration process. It is quite common, and you can spend more time with it if you want to try and get it, like all the data through. But sometimes you're just gonna have to cut your losses and say, okay, not all of it made it through, and just sacrifice that data. We could also see there was some shift in it, so maybe we didn't actually want that frame after all, because the stars were not really pretty, so it might actually do more harm than good getting that in. So for now, we managed to make it through, and we got the sulfur data in. So now we just need to do it for the oxygen, and we're again repeating the exact same process. With that, I like to take all my master lights, so all 3 of them, and just move them out here to the main folder, because now we just need to work on those. We're done with all our calibration, we're done with all our stacking, and we can move on to the next step. Because of that, I'm also just gonna change our folder here from the process folder, jump out. We actually need to jump 2 times out. We select that folder there and open that. So we are now in the folder. You can see the path here should match the path here where we put our masters out here. We are technically ready now to begin making this into color. So far, we've just worked with it as monochrome black and white data. But I like to do a little bit more tweaking on it before we move on to actually recombining this into color data. So let's just take our hydrogen master and open that up. There we go. Oh, look at that. It's very beautiful. Now, some of the things that I like to do at this stage is just, like look at it and can you see any noticeable background in it? If there's a background gradient where maybe it's dark in one corner and get light in another corner, then you might have a background gradient you want to try and fix, and you can actually fix that now if you want to. In this case, I don't really see a background gradient, so I'm not going to do it. Maybe when we begin to work with it as color and begin to stretch, maybe there's something that shows up we can try to fix later. But for now, it looks okay. So I'm not going to do a background extraction on this, but I'm going to show you how you could do it if you do see one. But what I will do is I'll do some noise reduction, because if we zoom in, we can see it's a little noisy in here in the middle, and we want to have clean Astro pictures with less noise. In one of the previous videos, by the way, I have a whole playlist of videos that goes over a lot of this stuff in Siril as well. I'll be linking that just below the link for the where you downloaded the data. And in that link, I showed one of the videos in that playlist showed how to get the Graxpert UI working integrated directly into Siril. This is an awesome tool that can do a lot of things for us really, really easily. I recommend you go and watch that video on the installation guide there on how to use this tool. The Graxpert does two things. It does background extraction, so neutralizing background gradients, and it does noise reduction with denoising. So if you need to do background extraction, you can decide how aggressive you want to be. Usually I leave it around the 0.5, but you can be more aggressive if you like. But you just basically click apply here, and then you're done. Okay? It should work quite well. If it doesn't, then go watch the video on background extraction, as I go into a lot more detail there on how to use this. But the denoiser we can use here now. So again, how strong do we want the denoiser to be? We could crank it, and in some cases that might work. In others, it may not. Often you probably wouldn't want to, but I think just for today, we're just going to try to crank and just see what happens, because this could be a good learning exercise as well to show a little trick I'm going to show you in a second. Quite simple, but very powerful. So for now, let's just crank this up completely, all the way up to max, and click apply once you got your Graxpert AI working. As I said, this is the add-on you need to install. Go watch that video on how to install this tool. And as it is now processing, this can take like a minute to let the tool go and denoise our image. Boom, there we go. Did you see what that did? It just brightened it up, and that's the auto stretch down here going in and saying, oh, like the signal to noise ratio is way better now. That's why the whole thing just looks so much brighter. Now, if we just close this down and we go and zoom in and look at that center now, and look at the before and the after. Like, that's a huge difference, right? That did a lot. So what we want to do with this now, and what I usually do, is I click this little arrow icon up here. And this was the hydrogen. So I would rename this to now _clean, and then save that as a new file. The reason to do this is, as I said before, sometimes you might later on down the line, when you begin to stretch, you realize this is a complete mess, and maybe you want to go back to the point and say, hey, hold on, maybe that like going full 100% on the denoise wasn't a good idea, and maybe I want to redo that with a slightly less aggressive denoiser, because or maybe you didn't like that it was like so smoothed out as it is when you go to 100%. That just means now you have the option. Now you have the different stages along the way that you can work with it. Like, we kept all our master files, so we can always go back to each individual step, do it again if we felt like we did something wrong, if we think we did something wrong. So this is why it's so important now to keep separate files as you are working with it, so you can always come back. But for now, we are just going to repeat the exact same process. Let's open up our oxygen. Gonna go up to the scripts, processing here, and again, maybe the oxygen has a bit of a gradient. You can see there's like, it's a little bit light out here, a little bit dark here. I can see a gradient in this, so we might actually want to just run that. Okay, now that looks a lot better. Awesome. Denoise, and I want to repeat the exact same thing for our sulfur data. Good. We now have the clean data for each of the individual channels, and now we're ready to getting some color in on this, and we're done looking at the gray and white images. Now, we're going to do this by going up to image processing, going into composition, and we're going to go to RGB composition. Okay, so Now we need to decide which of our 3 narrowband data channels, so we have hydrogen, we have sulfur, and we have oxygen, that needs to go into the individual channels. Now here we have an example of where these 3 different lines lie in the color spectrum. Don't worry about the colors here because they don't match at all. We can see here the red one here is our hydrogen alpha, the red one here is our sulfur, and this one over here is our oxygen. Now, as we can see here, now the oxygen is over here around 500. That's definitely going to be the bluest. So down here with the lower numbers is blue, and as we move up, it gets redder. So the oxygen here is the bluest we have with the lowest wavelength of light. We can see here both our hydrogen and our sulfur is actually sitting up here in the red area. Ideally, we would want one that was sitting in here around the 600 to be our green, but we don't really have anything in there. So what people usually do is they would say, okay, the oxygen here, that's gonna fit into the blue channel, as that's the one that's closest to blue. Sulfur is the reddest, that is the furthest up with the highest wavelength. So that's gonna highest wavelength. So that's gonna be the red, and then we're just gonna say, yeah, even though hydrogen alpha is very much a red color, we're gonna move that into green. And that's a very common way, and that's in fact what's called the Hubble palette. That's what NASA does with the Hubble data, and that's the way we get this like distinct color that kind of looks like what you would get out of the Hubble Space Telescope. So if it's good enough for NASA, it's probably good enough for us as well. So for the red channel, we are gonna take our sulfur clean, open that. For the green, we're gonna take our hydrogen alpha or H cleaned. And for the blue, we are gonna take our oxygen. Blue. Boom, there we go. Okay, we actually got something now we can look at, and it doesn't look very good, does it? First of all, colors way off. We're gonna fix that, it's not a big deal. Secondly, stars are not even aligned, like the blue is down there and those are up there, and it just doesn't fit at all. Luckily, there is just a very simple align button right here that you can click, and just magic stuff happened, and boom, stars are aligned. Okay, that wasn't too bad at all, after all. So now we got things aligned. I'm gonna close this, but before I do anything else, I'm gonna click the arrow, and I'm gonna save this as RGB. And we have that now. Again, just saving the next step here. Okay, now the first thing you will notice, of course, because we stacked, there is some artifacts here in the corner. So we're gonna just click and drag and begin making a use the middle out button inside the image. Drag that out there. Let's see. We can go a little further. We can go to like there, and then take this up. How far north can we go? Okay, we can go to like there. It's probably fine. Give yourself, don't go all the way to the edge. Give yourself a little bit of leeway. Okay, this is probably fine. Once we're happy with that, and we have a little bit of an edge out to the areas where we can visibly see that there is issues, we can right click, crop. Boom, there we go. Now we just crop that away, so we're not dealing with those areas anymore. Our data here is still in a linear state. So if we put this back to linear, we can see it's all black. That's because we haven't stretched anything yet. So what we can do now is we're gonna begin doing some stretching. So we go to image processing, stretches, generalized hyperbolic stretch transformation. So far we can see nothing. We can see the thin blue line in here. That's some of our data that's hidden in here. All the way, if we zoom in, we can see it sitting all the way in there. First order of business is to pull that data away from that edge. This is why it's black, because everything is sitting down there. We're gonna do that by applying some stretch factor. We can actually, if we move this over here and this over here, so we can see the image as we're stretching. So pull this up, slowly begin to pull this up until we begin to see some stars appear. That's good. Pull it a little bit further. Now we begin to see some of the nebulosity. And what I like to do then is just pull it back with some highlight protection here until I see that begin to drop. That just prevents the stars that we can now already see from completely clipping, right? So we're not overexposing our stars right away, but we can still see here we did manage to pull that data away from that edge. Okay, so let's go ahead and let's click apply to this. What we're gonna do next is we're gonna zoom in using this plus icon here until we can until we can see the individual peaks here. And the reason why the colors are so off, because these peaks are not aligned, so that the blue here is way stronger than some of the others. So what we're going to do is we're going to deselect the blue, and let's start by just focusing on the green. So let's start by adding some highlight protection, pull that down to around half. And now we just pull this one up until the green, we can use the plus here to be more accurate, until the peak of the green aligns up with the peak of the blue. Okay, so whichever is highest for you, take the lowest one or the lower ones and pull it up towards. Never stretch backwards, never stretch down, always stretch up. Okay, if you need to stretch backwards, you would probably need to just undo a few stretches and go back. So now we're stretching it upwards until those are aligned. We can click apply. So now here, I'm gonna go and deselect this one, select the red, highlight protection. I'm gonna begin to stretch it here until those peaks are aligned up, like so. And apply. And actually, you know what we might wanna do? We might actually want to try and align it up so the base, the right, so the left side of the base peaks here are lined up. I'm just gonna do that. I think that's actually gonna give us a slightly better result. This is gonna mean we have a darker, so I'm gonna try to make it so that the peaks doesn't necessarily match each other. Okay, if we go out now and do an auto stretch, we can begin to see, okay, now it's just very, very green. And the reason it's green is you can see that green, that was the hydrogen alpha, that's the strongest channel. You can also see how this is higher out here. That's because that's the green channel that's very, very prominent out here. Now, there are multiple ways that you can fix it. We could try to go in and stretch our way out of it by carefully beginning to widen these peaks here one at a time by trying to like open them up with stretching so that the peaks become wider until they kind of match a little bit more. Often what you can do is we can just go into the image processing and use a green noise removal. And that is actually made a pretty decent result here. Now you can see the colors now are very muted. And that's fine. That's something we can fix, like they're very subtle, the colors, but they're there. Now we can stretch the data a little bit more. We're back on a linear view here. What I usually like to do is to go back to a zoom level of 5 here, apply some highlight protection, and then raise those peaks upwards until we begin to see some data here. And it depends a little, but often I find if we hit it around that line there, it's probably fine. You can try to hover over some of the dark areas where there are no stars. And a good rule of thumb is to try and get those numbers, look at the numbers down here as I hover, try to get those like between 10 and 15 is usually a good point where to keep the background at that. And when you get to that, then you can go ahead and apply it. And we're gonna try to keep the background at this level by not moving these peaks anymore, but only widening them out. We've already gotten quite far. We can actually see the nebula now. We can begin to see some of the data that looks great. Awesome. So what we can do is just continue to stretch. But what we can do is go ahead and take one of the darker part of the nebulas. So don't take like the brightest point, like up here, right? Take a darker part, like around here, and maybe like include a larger area so we get something to work with. And then click the little symmetry point here. Now when we stretch, what we can do is we can now stretch upwards and then use that highlight protection to pull it back. And you can see now when the base here, we keep the base here at the same level, but notice how the green has moved up and all the color channels have actually moved up that way. That just meant everything got brighter, even though we kept that background level still at around those 10 to 15. That hasn't moved much, so that's great. Let's go and apply that. And just so you can see the difference here, that was before and that was after. And we're slowly working our way up. And our colors are still very muted. So we can now say, okay, this area is beginning to brighten up a bit. So maybe we want to say, hey, can we maybe try to, maybe not this, but this area here, can we try to work on, it's not that we're just working on this area, we are working on the entire picture, but we're using that and saying, hey, we want to focus on getting areas like this, as like our focus area, like lightness level as a focus level, if you will. So again, we're gonna stretch upwards. And now we need to begin to be careful here. Pay close attention, identify the brightest spot in your nebula. So that could be in here. It could be up here in the tip, probably around here is probably one of the brightest spots. Hover over it with your mouse and say, hey, how does that look? Is that peaking? Because if I just kept stretching this, you can see how this area now gets overexposed. I begin to lose data. I could then reclaim some of that by pulling back on that highlight protection. You can see here how it's overexposed. We're peaking up at like 98%. Pull this back on the highlight protection so that the base here haven't moved much. That's approximately where it was, where it was before. Now this is sitting at around 80%. That's a lot better. Okay, awesome. Let's click apply. Okay, I'm actually kind of liking where this is right now. I think it looks kind of cool. One thing we can do, because this picture is actually mirrored right now compared to what it should be. And if you're not really sure what way the picture should be, I mean, you can point it any way you want. It's in the night sky. You can do what you want with it. But sometimes I like to just go into the tool, Astrometry, Platesolve, and then type in the number. I think this was this IC, was it 1805, I think? And click find, yeah. And then you need to type in the focal length of the telescope and the pixel size. This is where those FITS files comes in handy, because as I said, a lot of that data is stored in those FITS files. If it isn't for you for whatever reason, then this is the data that you're going to be using for this. And the important thing is to flip image if needed, and just quickly Platesolve the image, and it's going to rotate the image so that it's actually rotated the correct way. Let's go ahead and we could save this as a new one if we want to. We had the RGB before, right after we recombined it, so we could call this RGB stretched, maybe. Save our RGB stretched. Okay. Now we want to do something about those muted colors here. Okay. And we are. But I actually don't necessarily like to do this in Siril. I'm going to show you a few ways you can do it, but I'm also going to show it the way I prefer to do it. You can go into the stretch here, again, the generalized hyperbolic stretch transformation. Instead of going independent channel values, you could do a saturation stretch. We can actually do the exact same thing. We just highlight protection so we don't blow the colors completely, and then we can begin to stretch here. And what you will see happen is that the colors begin to get more saturated as we do this, right? Be careful with this. You can do a little bit, that's fine. This is just a more advanced version of just having a saturation slider you slide around with. It's very easy with a saturation slider to, where you don't have access to this high protect here, to just oversaturate. So this is why if I do saturation changes, I like to do it in here. But for now, I think let's just apply this. This is one way to do it. I'm going to show you another way to make the colors pop even more when we get later on into the edit. But there is a step that I like to do now. Let's go ahead and save this. And that's because at this point, I often like to separate my images out in two. And what I mean with that is I like to take the stars out of the picture. So I have the stars in one picture and the nebula in another. And that allows me to do some color tweaking to the nebula without affecting the stars. And then I can put the stars in on top, and I can maybe even do a star reduction so that the stars are not so prominent, or boost them if I prefer that look. And this is where I can begin to play around and be creative. Again, I have a video on the playlist that I mentioned earlier that talks about StarNet and how to get StarNet installed. This is another add-on that's super handy and super powerful inside Siril. So go to the playlist if you don't have StarNet installed already, and go ahead and get that installed. We're going to go to image processing, we're going to go to star processing and StarNet star removal, and we're just going to open it up. Pre-stretched linear image, we don't need to do that, we've already done that so far. Generate mask, generate star mask is important, and then click execute. And now magic stuff happens. Look at this. And like that, boom, stars are just gone, just gone out of the image. And now we just have the nebula. It's amazing. What has happened is, you can see here, we now have two images, fits files out here. We have a starless RGB and we have a star mask. This is the starless that we're looking at now. And if we take the star mask, you can see that contains just the star field. It's awesome. It's really, really awesome. I really like it. What we're going to do now is, these are still in fits format, and we're going to move over to a tool called GIMP. This is a free image editing tool. It's a bit like Photoshop, it's just free, and has a lot of really strong tools, and especially I like to do my final fine-tuning and tweaking over there, because I think it gives a better result when it comes to those final column tweakings that I like to do than what we get in Siril. Siril is strong for everything we've done so far, but for the final touches I like to move over to GIMP. GIMP does not, however, understand fits files, so we need to convert it over to something that that GIMP can read. So we're going to open up the two files we got out of the starless and the star mask. First, let's just take the star mask because that's what I have opened. Click the arrow icon here, and instead of saving this as a fit file, we're going to save it as a TIFF, T-I-F-F, and save. TIFF, here are the settings, by the way, that I usually use. TIFF files are just an image file, just like JPEG or just like PNG. It's just a lossless image format. That means that we don't compress the data. You can see it is the same size as the two other images. We have the same data in there. We haven't compressed anything away. And that's why we use this. So that was the star mask. Let's go to starless. This is why I use this format, because we don't want to lose data. We are going to make it into a more readable image format later when we are done. But for now, we don't want to lose any data. We do that at the very last step when we throw away all our pretty data here. Okay, so take that, make that into a TIFF, and save. Okay, great. Now we have those two as TIFF files. So let's go ahead and let's fire up GIMP. Okay, once in GIMP, we're gonna take our two TIFF files and just drag and drop them in. They're gonna ask us to convert. We're just gonna convert. That's our star mask. Take our starless. Boom. Out here on the side, we can see they're now in two different layers. We're gonna drag and drop the star mask on top. And then we are going to click the little eye icon next to it to hide it. Because right now, we just wanna do some final tweaking here on this, on the nebula itself. And then we're gonna go and fix the stars later. Okay. Let's go up to the color drop-down menu here, and let's start by just playing around with the levels. We want to try to make the... Why didn't that open? Oh, great! I had the star layer selected. I need to go, of course, select that layer, the nebulosity layer here, and then click levels. Jesus, Astro. Okay, here we go. What I like to do now is just to darken the background a little bit. So by taking this little arrow here and dragging that up towards the base of the peak here, and just look at that contrast we're getting there. We can go and do a split view here if we want to, just click that, and we can now see side by side what kind of change we're making. Just look at that, and we can maybe be a little bit more aggressive. I usually don't want to go all the way up to the base, because then the background just becomes completely dark. Maybe you like that look. Of it just being completely black around it. I like that you can see a little bit So I'm gonna keep it there. So I can still see that there is something out there that is not completely black. It just makes the picture look more natural. But that already look a lot better. But there is a slider in here that's just my favorite and probably one of the main reasons why I use this tool. Look at this. Still with the nebulosity layer selected. We're gonna go to colors and we're gonna go to hue and chroma. Or chroma even. Wow, not chroma, chroma. And here you have this chroma slider. This we need to be careful with. I slide that too much and your image is gonna be way out of whack. But if we just, this is just like a saturation slider on steroids, right? If we can do a split view down the center here and drag that in there, just look at how it takes the blues here. This is what I really like about this tool. It just takes those blues and just all the colors in general, but especially those deep blues, and it just makes them pop. Like, look at this, right? Like before, after. Muted, super bright and pretty. It just does a lot, and again, you just need to ever so slightly. Don't move it a lot because then it's all over the place. I'm pretty happy with where we are with the nebula now. So now we can begin to work on our stars. So let's go and click that and we can see our stars again. Now they're gonna overlap right now, but by just selecting the star layer, and then you go up here where it says mode and it says normal, take the drop down menu. Now there are two ways you can do it. We can actually do this. This is called a star recomposition, where we put the stars back on top. What I believe it does in Siril, if you do it in there, is use the screen method. And to my eye, this looks like the stars are painted in afterwards. They're like a screen film that's put on top, kind of indicating the name, right? I don't like that look. I want the stars to feel more integrated into the picture. And for me, if I go instead to addition, it looks more natural. I'm not sure how well it's going to show up here on YouTube, but to me, this just looks better. Okay, so now we have our stars back in, but we can do more now that we are actually here. Because one thing I usually like, and this is where it's just personal preference, right? With still the star mask selected, I like to go to colors, go to curves. I like to do what's called a star reduction, because with this curves tools now, I can just pick the middle, and if I drag this downwards, look at the stars in the picture. Look at that, how they get reduced. They get smaller, right? If we go back to the center, let's zoom in on some of the stars, we can see it close up. As I drag this point down, look at the stars. You can see how we can just reduce the stars a little bit so that they're less prominent, and they don't show up as vibrant, as powerful as they did before. I like to do a small star reduction, where the stars just are pulled a little bit down. You can also, if you really want like a really star-infused picture, where all the stars are super prominent, you can pull the other way, and you get something like this. This is essentially stretching. It's exactly the same as stretching. We can really pull the stars out if you want something that's just like a sea of stars. Some people actually like the look where the stars are not there at all, just go completely starless. I don't personally like that look. I like to see that the stars are there, but I like them to be reduced so that they are not as prominent. Something along this line here, I think. And again, personal preference. This is the I kind of like it so that the nebula is in focus. I'm pretty happy with this. The only thing we need to do now is to click Ctrl-Shift-E for export. And then we're going to convert this over. Let's call this one for IC1805. And then we're going to go and make this into, first I like to make, a PNG. And export as a PNG. Once we're done, we can go and export the other one. You can also go to the file menu and click export as here if you want to. And then we're just going to change this to JPEG, export, and export. That's a lot faster. And now we can see we have those files here. You can look at the file sizes, right? This is 146 megabytes. This is 13 megabytes, still a large image. You could crop it down to size if you want something that's not as high resolution. There we go. That's our final image, fully processed from raw data to finished image. in Siril, and a little bit of GIMP for those final color tweakings that I like to do. And down here, you can see that you have the Graxpert X that you need to set. I have already set mine here because I've been testing it. The StarNet star removal is going to begin, and it can take a bit of time, so by the power of video editing,